There's no doubt that regardless of your political persuasion or perspective, all agree that climate change and carbon will be a political and legislative issue in the months ahead. The Biden administration has already announced that they will re-enter the Paris Accord, which will come with real and specific measurements that will need to move through Congress to address climate change. So now we have a forward-thinking presentation about moving towards a lower carbon world presented by Dr. Rob Zeller, Vice President of Technology with Oxy Low Carbon Ventures. We're excited to hear from Oxy Low Carbon Ventures about how they are advancing their vision of a low carbon world by focusing on reducing Oxy's total carbon impact by decreasing operational emissions, increasing energy efficiency, and capturing and retiring more carbon than their products create, and providing solutions to others looking to do the same. Dr. Rob Zeller is Vice President of Technology for Oxy Low Carbon Ventures, OLCV, a subsidiary of Occidental. In this role, he leads a team developing cutting-edge projects using carbon capture, utilization, and storage technologies. Prior to joining OLCV, Rob spent nearly 30 years with OxyChem and subsidiaries of Occidental. Rob, thank you for joining the Vinyl Institute today.
So Oxy Low Carbon Ventures, what do we do? So for us, low carbon leadership means going beyond just reducing our own emissions, which is why we formed this Oxy Low Carbon Ventures. So we investigated new technologies, and I'll touch on those briefly in a second. We implemented we've teamed up with different people or different companies that we work to capture their CO2 emissions, and we certify that sequestration process so they qualify either for, say, the low carbon fuel standard credits, or to qualify for 45Q tax credits. In the case of vinyl, it could be qualifying for additional LEEDs credits by reducing the carbon intensity of your vinyl product. So there's a potential tied to carbon intensity in the markets for which vinyl participates. We also, going around, so innovations on CO2 capture separation, we've invested in a number of technologies there. We've installed a solar field that actually is behind the meter out in our oil and gas operations, and we're doing some other innovations around that investment. We also do a technical advisory services where we are providing input around the world. We're in 3 continents today, telling and teaching people how to look at the subsurface to see if there's a good spot, so to speak, to sequester CO2. And we're providing those services in Australia, United States, UK, Switzerland, and other locations in the Middle East, or other locations in the Middle East. Next slide, please. So from a business action summary, there's really 3 key areas that we focus on: technology, projects, and services. Starting on the left-hand side, these are some of the partnerships that we have entered in over the last couple of years, and I'll be focusing a lot on the carbon engineering side of that. But carbon engineering is a company that does direct air capture. It actually physically captures CO2 out of the atmosphere, and it concentrates it up into a form that we can actually use it in our enhanced oil recovery process. Net Power is an investment. It's an emissions-free 24/7, 365 power source. So unlike solar or wind that go away when the sun sets or the wind doesn't blow, this is an emissions-free power that's 24/7. Cemvita Factory is an interesting CO2 utilization technology. It converts CO2 into products, and we're looking at complementing our chemical businesses with that Cemvita Factory technology. Lithium is a lithium extraction technology to make battery-grade materials. Exchange is a carbon trading platform, so that we take CO2 and we sequester that, but to do a B2B or a compliance-based trade with a government, for example, to meet their climate ambitions, there needs to be some sort of third-party certification, and exchange is part of that process. Carbon Finance Labs is part of that process also, except they look at what data and how do you bundle that up into a particular manner using blockchain and that sort of thing. The membrane universal technology tester is something that we're taking, what we'll call it like a beauty pageant, where we're bringing different technology suppliers in. They say their membrane is super fantastic. Well, we trial it in our test unit to either confirm it's great or say, go back to the drawing board. In real life, it doesn't work. So that's something we're doing in technology. Project, I'll be touching on 1.5, which is the development company to make some of these things a reality. White Energy is a project where we're capturing CO2 from an ethanol plant. Colorado CCUS project is CO2 off of a cement plant. We're working and partnering with the Department of Energy, talking about infrastructure and putting in CO2 superhighways to go from point source emitters down to sinks, such as we have in the Permian Basin. And then from the services side, we do complete turnkey sequestration, where we can put in the capture facility, we can put in the sequestration, and provide a certificate that gives you 45Q tax credits or whatever other opportunities there are, so that you can prove to whomever's interested that CO2 is permanently sequestered. And we do things, even peer reviews. You have an external team that has said, here's the answer. We can go in and give a cold eyes view of how things are done. Next slide, please. So the picture on the left-hand side is the artist rendering on what the direct air capture plant actually, how it looks, or that's our first look at it. In the foreground, you see those are really cooling towers. Those are the air contactors. And then as you get farther and farther into the background, there's different processing units in terms of how that technology works. So, so we've, through our due diligence, we looked at a lot of different technologies for direct air capture. We chose carbon engineering because we feel that they are the premier at-scale technology to capture CO2 out of the atmosphere that we can then use to assets. We have in Racine, we partnered with a company that's done first-of-a-kind financing of projects, and with us, we're bringing together our know-how, our infrastructure that we have for handling CO2. We have know-how on scaling first-of-a-kind technologies. And we know how to do billion-dollar projects and bring them in on time and on budget. We've done it and demonstrated that. So if you look at this note here, so what Oxy's bringing is our oil and gas infrastructure and something we call certified pore space. And what we're in that sequestration process, we're producing something new, a low carbon oil, which is a solution for hard to decarbonize industries. And we'll talk a little bit about that in a moment. Next slide, please. So this is the carbon neutral energy cycle, and this is a core foundation of what Oxy's trying to do. So let me just put it, and really this is to solve the solution for hard to decarbonize industries such as rail, aviation, maritime shipping, long haul trucking. So let's just frame the story. So let's just say you actually can travel and you want to go on your dream vacation and you want to take an airline, but you're worried about the carbon footprint of that travel. So in this case, the airplane takes off, the CO2 goes into the atmosphere from burning that jet fuel, and you're on your way to your destination. But what you can envision is that over there in West Texas in the Permian Basin, there's these industrial plants that are pulling CO2 right from the air. Yes, it's directly from the air. And since the atmosphere is like a one big giant pipeline, it goes from your tailpipe of the aircraft all the way to the West Texas Permian. So that's captured, it's put into a liquid form, it's moved into this extensive network of pipelines that we have in the Permian Basin, and we inject it into certified oil and gas reservoirs that are part of the EOR operations. Well, as part of that process, that CO, the oil comes out, essentially making room for the CO2 as it gets sequestered, and the CO2 becomes trapped. But in that process, oil is produced, And that oil just so happens it can be carbon neutral, it can be carbon negative, it can be low carbon oil. It all depends on the functionality and the performance of the reservoir. But that oil actually enters into the supply chain and goes to the refineries, goes to the airline. Things are fungible, meaning that you move oil, this oil for that refinery, you pass the attributes around. But the point being is pretty much everybody keeps their job. Throwing away aircraft that still have a 20-year life on them, or getting rid of maritime ships because they don't have the right propulsion system. What this does is the refinery guys keep their job. The guys that are transporting and moving product at the airports are keeping their job. And so it minimizes societal upheaval. It's going to cost a little bit more money, but it's going to basically have a carbon neutral barrel of oil and a circular carbon neutral energy cycle. That basically the amount of CO2 that's going underground is basically equal to the amount of CO2 that's part of what's called scope 1, 2, and 3 emissions. So basically from wells to wheels, all the CO2 that you sequestered is what would be generated from the use of that hydrocarbon in your jet. So at the bottom line, you should feel good. You'll know that jet fuel that goes into that plane, and you should feel no hesitation going on your green vacation, knowing that your carbon emissions are part of the carbon neutral energy cycle. Next slide, please. So what this slide is supposed to represent is, yeah, that's a great story. You're going on your green vacation. But ultimately, this approach needs to be accepted by the world. And so what we're trying to be and what we must be is we must be transparent and have third-party verifications of what we're saying. So we partnered with Carbon Finance Labs to help us navigate this. So to have an internationally recognized ton of sequestered carbon, you need to have a proven methodology with a certified full life cycle analysis. It must be verified and have a high quality monitoring, reporting, and verification plan that's certified that the CO2 is permanently stored. And we also need to have we need to participate into a trusted registry for recording the creation of that registered carbon ton, a way to trade that registered ton amongst different parties, and a way to actually retire those tons to offset whatever issues or whatever carbon emissions that are going on with the other business or government. And this is all for businesses and governments to meet their climate ambitions. Blockchain is part of that, and there's a bunch of data that are associated with that sequestered carbon. The second step in this pyramid is we need to socialize the process. And part of what I'm doing here today is to talk about it so that you can consider this being part of the solution to address climate change. And finally, at the top, we need a uniform registry and a trading platform, and that's where our partnership with Exchange occurs. And they're the premier carbon platform, and they help us facilitate that process. Next slide, please. So for this group at the Vinyl Institute, I wanted to touch on our technical advisory services group that can, if you have an interest in to explore how you would meet your climate ambitions. As I said earlier, we are supporting industrial emitters to evaluate and engineer carbon capture projects for their facilities. We can quickly and reliably address your options. We can partner with you. We can provide turnkey carbon management solutions, or we can be an independent third-party peer review on whatever plan you have. What differentiates us from others in this space is that we know what to do economically and what is not justified that is often recommended by others, because we've been doing it as a business for 40 years, and we're doing it today. We offer a suite of services that range from a rapid assessment to a full project engineering. So you can see the things on the left-hand side there. Next slide, please. So how do you get economics out of this thing? So on the left-hand side, let's just say that's your industry. Well, if you put a CO2 capture plan in, and that could be done through a capture code, that could be a joint venture. Sometimes the emitter themselves integrating that into the facility wants to do it themselves, fine. But where Oxy's expertise really comes in is the pipeline transport, permanent sequestration, generating the certification associated with that. So you can get 45Q tax credits. You can use that certificates into leads, for example. You can go into other markets that have Going into Europe, they're talking about a carbon tax for imports. They're just talking about cement and steel, but there's no reason why chemicals wouldn't be following shortly behind that. And so certifying low carbon is going to be something that's important. And what this shows through our technical advisory services group is Oxy is also evolving into a carbon management company. Next slide, please. All right, so I'm going to conclude now. I hope you see that Oxy is striving to be the premier carbon management company for the U.S. and the world. Our new development company, 1.5, is taking our aspirations and making them a reality in the U.S. Our differentiated carbon neutral oil product could be part of the solution for hard to decarbonize industries such as aviation, maritime shipping, et cetera. And we are working for it to be recognized in international trading markets. Our technical advisory services group are helping like-minded partners meet their climate ambitions. Oxy is moving to be a part of the solution to address climate change. Any questions?
Rob, thanks very much. That was a fascinating presentation. Really science fiction. So wondered if you could answer a couple of questions that have come up. First is with respect to the permanent sequestration of CO2. I understand that you've got it demonstrated in the Permian Basin, but you mentioned during your talk that Oxy can help identify other potential locations to permanently sequester CO2. Could you elaborate a little bit about that?
Sure. One of our clients is Santos in Australia, for example. They're an oil and gas producer, and so we helped evaluate their subsurface to see its suitability for EOR. We've also consulted in saline aquifer formations, because when people think about injecting CO2, they think it's like, remember the Jules Verne Center of the Earth movie or book? They think it's a big open bubble underneath there with that you just put this gas in there and it's just waiting to erupt if you crack open the earth like an egg. But it could be farther from the truth. We're injecting it into a porous, like sandstone, calcium carbonate. It has porosity in it. And so what you're doing is when you're injecting the CO2, you're either displacing the oil and the water that's down there, or you're displacing, say, brine that's down there. And as that CO2 sits there, it actually dissolves in the water, and that's one of the trapping mechanisms. It gets stuck because of surface tension into the fine little pore spaces. That's part of the a trapping mechanism. But ultimately, over years, it will react with the calcium and magnesium that's underneath there and actually form more rock. So it's, how do we know that? We have decades of experience on subsurface characterization, how to handle CO2. We've done it, for 40 years. And so taking that, we're consulting in European organizations. Most of them don't want to put sequestration on their, behind their backyard, so to speak. So we're doing offshore evaluations in the North Sea and some places like that on characterization of that subsurface stuff. How is that important? You want to know. It's always a balance, because if you're doing a saline aquifer sequestration, there's a hydraulic balance, because you're pushing something in there that's already balanced. So you got to make sure that the porosity of the rock is right, so that you inject at a certain rate. What's the capacity of that? What's the cap rock look like? Because you don't want to damage that cap rock that's basically sealing all that CO2 in there. And so you can get some fly-by-night garage. In my garage, I can put a hole in the ground and inject CO2, but you're really putting yourself up into an unreliable situation. And that's what we bring in, is we bring in that capability. Hope that answered your question.
Yes, we're getting a lot of questions, Rob, so very good topic. Let me switch to more economic questions. So I've got a number of economic questions. First is, are the government subsidies or tax incentives required to make this work? And secondly, is the expectation that the economics will become more viable in the future?
Sure, great questions. The President Trump in early 2018 signed the Future Act as part of the omnibus bill. That was the catalyst to form Oxy Low Carbon Ventures. So they pay these tax incentives. If you put it sequestration in EOR, it's $35 a ton, and if you do saline aquifer, it's $50 a ton for CO2. That tax incentive was designed to pay for the capital of the project. Okay, and so a lot of and that is important as a catalyst to put these things in. Other incentives, there's some California Air Resources Board has a low carbon fuel standard pathway. And so our partnership with White Energy, they're going to be moving ethanol with a significantly lower carbon intensity, which makes it much more valuable into the California market. And that's what drives their incentive to go do that. So it is a compliance-based incentives. If there's no cap and trade, there's no carbon tax. But as you look at export markets, if you're playing in Europe, they have a carbon tax right now, and they're looking at expanding that. And so it's maybe you don't execute, but in our plans, we have a United States exclusivity for carbon engineering technology to build many plants. And our expectation is we're going to build the first one, we're going to figure it out, and when we do generation 2, we're going to be that much smarter. When we do generation 3, generation 4, and so we expect cost to drive down with each generation 10 to 15%. That's well proven per Wright's law, and we fully expect that just by understanding the supply chain, improving. Because when you look at these air contactors, you don't just have one air contactor. You have, say, 160 air contactors. So if you have some smart guys there that are throwing out how the wrenches are throwing out there, and you talk to the guys that are doing the work, you might want to drill a bolt hole a little differently. And so that as you do this through repetition, you're going to get smarter on how you do that. As we improve the technology on capturing, we're going to go from 160 air contactors, for example, to 120 air contactors. There's a lot of room for improvement that's going to drive costs down, both CapEx as well as OpEx, and we're very optimistic. And for those of you who are chemical engineers, every unit operation in carbon engineering technology I've played with in my career, 30-year career. So I've screwed them up. I know how to run them, and we brought over a lot of the OxyChem folks that have done that same thing to make this a success.
Rob, another interesting question has come up, and that's a really good answer with respect to economies of scale and the economics. Another question has come up. Today's technology is about sequestering, but do you envision any new uses for CO2? I know you mentioned that it reacts with some of the other minerals underground and creates rock, but do you see some other potential uses? I know I've read about just converting CO2 into plastics.
Sure.
The potential technology or use, but what's your view on that?
When you look at where's the biggest emission of CO2, where's the biggest carbon used in the world? It's used in fuels, right? It's very hard to take CO2 and make it into a fuel. Usually you need hydrogen. To make hydrogen, you use electrolysis of water, and that's an energy hog. And so when we look at using enhanced oil recovery and CO2 that way, making a fuel via that path, we think we can do it at scale and do it for a lot less money for decades. With regard to utilization, what's the biggest commodity chemical out there? It's ethylene, right? So if you could convert CO2 to ethylene, that would be both have a lower carbon intensity. You'd be able to sequester the carbon into a long-lived product such as vinyl, an underground pipe or pipe valve and fitting type of stuff. And we are working on that. That's really related to the projects that we're working with Symbita Factory, as we're using some very innovative technology to go from CO2 to ethylene is where our target is, as well as some other chemicals. There's people out there that use electrochemistry to make a syngas. Once you make syngas, you have a portfolio of things you can make, from methanol to other products. And so there's a lot of study going on there. There's a lot of companies that are on the cusp of being commercial. And I think there's going to have to be some government policy that's going to really push them over the edge. In our case, I think that the LCFS and some of the polls from like aviation. Aviation has a CORSIA compliance target in 2026 from a jet fuel perspective. They don't have a way of getting there. It's a UN treaty for international travel. You have to have a certain carbon intensity fuel, and they don't really know how to get there. Biofuels can't do it. Even if you planted the entire United States and covered it with bio stuff and converted all that to fuel, it ain't enough to feed the airline industry. So it's this is a solution that intrigues them, if that makes any sense at all.
As you well know, fossil fuels are a high intensity energy source. So these technologies with respect to sequestration and new uses are just, it's the wave of the future, that's for sure.
And certainly this allows a little time. You know, nobody wants to buy a $100 million ship and then have to retire it after 5 years. You want to fully depreciate it. So this allows a pathway to get to whatever the next technology is decades from now.
Well, good luck to you. I think we're all thrilled that this is coming up now. So want to thank you immensely for your presentation today. It's fascinating and it's very encouraging for our industry and for our lifestyle. You know, we depend on fossil fuels immensely. The notion that the alternatives are going to be planet saving, I think the things that you're working on are the real, where the rubber meets the road kind of technologies that are going to eliminate CO2 from the atmosphere or create new uses for it. And it's something that'll help us thrive for generations and millennia to come. Thanks very much, Rob. And let me turn the program back over to Ned Monroe.
Thanks, Rich, and thank Rob. It was a fantastic conversation. Again, something a little different for the Vinyl Institute, a little cutting edge, explore some other alternatives that are out there. And based on the comments and the number of questions, Rob, I think we'll probably have some additional sessions on this, maybe at a future operating committee or board of directors meeting, so we can continue having this conversation, because obviously this is an area that policymakers, elected officials, business leaders are all very highly engaged in.